war in Pakistan just took an unexpected turn. Recently, a strange jet was spotted on one of the world's most powerful aircraft carriers in the world. This jet is said to be one of the most technologically advanced aircraft to be created. Its capabilities and designs stand as a proof of its lethality and power, easily intimidating other aircraft that comes its way. Recently, this strange jet was spotted near Pakistan and has stirred up a state of unrest amongst other nations. What is this strange jet that was spotted on the USS Gerald R Ford aircraft carrier? Why is the United States anywhere near Pakistan? Join us as we explore the advanced capabilities of the strange jet that was spotted on the U.S. most formidable vessels. Since the global war on terrorism began in late 2001 and the subsequent United States invasion of Afghanistan to oust the Taliban and Al-Qaeda, the U.S. has carried out numerous missions into northwest Pakistan. These missions aimed at militants linked to the Afghan conflict, who allegedly sought refuge in Pakistan's tribal areas. Pakistan has vehemently protested these actions as violations of national sovereignty, leading to tense diplomatic relations and significant public outrage. These operations have fueled anti-American sentiments among Pakistan's civilian population and politicians. Since June 2004, the United States military has launched dozens of drone strikes targeting presumed Taliban hideouts, resulting in the deaths of hundreds of militants and civilians. The intensity of these strikes increased after 2009. Pakistan has heavily criticized these drone operations, arguing that they are counterproductive, as they risk uniting the border tribes with the Taliban against the United States. Although Pakistan initially coordinated with the U.S. on some missile operations, the U.S. later began conducting these operations without notifying Pakistani authorities. This led to Pakistani troops being ordered to counteract these unannounced strikes, escalating tensions but not leading to any serious diplomatic fallout so far. Recently, a strange jet from the United States was seen near Pakistan. This aircraft, later identified to be the X-47, is a technological marvel that has earned its respect and fear in the skies. The Northrop Grumman X-47B is a cutting-edge unmanned combat aerial vehicle designed to operate from aircraft carriers. Developed by the American defense giant Northrop Grumman, the X-47B started under DARPA's JUCAS program before transitioning to the Navy's Unmanned Combat Air System Demonstration Program. This sleek, tailless, jet-powered aircraft features a blended wing body design and can perform semi-autonomous operations, including aerial refueling. Taking to the skies for the first time in 2011, the X-47B has since undergone extensive testing. By 2015, its two active prototypes had successfully completed numerous land and carrier-based demonstrations. In a historic achievement, the U.S. Navy announced in August 2014 that the X-47B had been integrated into carrier operations alongside manned aircraft. By May 2015, the primary testing phase was officially complete. Although initially slated to become museum pieces, the Navy decided to keep the X-47B demonstrators in flying condition for potential future development. This decision reflects the ongoing interest in exploring the capabilities of this revolutionary aircraft. The development of the X-47 began with the Joint Unmanned Combat Air Systems Program, or JUCAS program for short. The program from the early 2000s was a joint effort of the U.S. Navy and Air Force to build a formidable unmanned fighter. However, in 2006, the program was terminated. The United States Air Force opted for a new next-generation bomber, while the Navy maintained its faith in a fighter drone and revived the JUCAS program in a new solo program called the UCAS-D. It was in this program that the X-47, which had already been put forward by Northrop Grumman in the JUCAS program, would take shape. The U.S. Navy took a major step into the world of unmanned combat air systems in 2000 years by awarding contracts worth $2 million each to Boeing and Northrop Grumman for a 15-month concept exploration program. The goal was to tackle the unique challenges of operating drones from aircraft carriers, such as dealing with corrosive saltwater, managing deck launches and recoveries, integrating command and control systems, and operating in high electromagnetic interference environments. The Navy envisioned using these drones for reconnaissance and to penetrate protected airspace to identify targets for subsequent missions. Northrop Grumman's proof of concept, X-47A Pegasus, which laid the groundwork for the X-47B, first took to the skies in 2003. Despite the termination of the JUCAS program in 2016, the Navy pressed on with its UCAS-D program, selecting the X-47B as its demonstrator. It was designed to match the size and weight of an operational craft, complete with a full-sized weapons bay capable of carrying existing missiles. A team of industry giants, including Lockheed Martin, Pratt & Whitney, and General Electric, joined forces to bring the X-47B to life. The prototype rolled out from Air Force Plant 42 in Palmdale, California on December 16, 2008. Although its first flight was planned for November 2009, delays pushed the timeline back. However, progress was made with towed taxi tests in December 2009, and by January 2010, the X-47B was taxiing under its own power. This groundbreaking project marked a significant leap forward in the Navy's UCAS capabilities. The X-47B demonstrators, AV-1 and AV-2, took their first flights at Edwards Air Force Base in 2011. Originally set for a 3-year test program, they impressed so much that preliminary tests concluded after just 16 flights. The Navy then focused on carrier launches, recoveries, and autonomous in-flight refueling. A wearable remote control system was tested in 2012, allowing ground crews to maneuver the drone on carrier decks. In November 2012, the drone began its carrier-based evaluation aboard the USS Harry S. Truman, and by May 2013, it had successfully catapulted off the USS George H.W. Bush, marking the first UAV launch from an aircraft carrier. A series of historic achievements followed, including touch-and-go landings and the first arrested landing of a UAV on a carrier. The X-47B continued to demonstrate its capabilities, achieving significant milestones like night flights and operations alongside manned aircraft. In April 2015, it made history again by completing the world's first fully autonomous aerial refueling. Despite initial plans to retire the X-47B demonstrators, the Navy maintained them for further testing. In 2016, the Navy decided to shift the X-47B's role from surveillance and strike to reconnaissance and aerial refueling, with limited strike capabilities. This decision followed a restructuring of the Unmanned Carrier-Launched Airborne Surveillance and Strike Project, paving the way for the MQ-25 Stingray program. To achieve this, dollar numbers had to be high. The project was initially funded under a $635.8 million contract awarded by the Navy in 2007. By January 2012, the X-47B's total program cost had grown to an estimated $813 million. Government funding for the UCAS-D program was to run out at the end of September 2013. However, in June 2014, the Navy provided an additional $63 million for post-demonstration development of the X-47B. The Navy was ready to shell out big bucks for the drone, and for good reason. It was poised to revolutionize sea-based warfare. This unmanned combat air system was designed to breach enemy airspace and pinpoint targets for subsequent attacks. These strikes could be delivered by more heavily armed aircraft, or the X-47B itself. While primarily built for reconnaissance, the drone packs a punch with 2 weapon bays capable of carrying up to 4,500 pounds of ordnance. It's not just about firepower, though. This drone is a nimble beast. Equipped with a Pratt & Whitney F100-220UU turbofan engine, it also boasts an impressive near-supersonic cruise speed of Mach 0.9, a service ceiling of 42,000 feet, and an operational range of 2,400 miles. Led by Northrop Grumman, the X-47B was developed by an entire army of powerful subcontractors, including Lockheed Martin, Pratt & Whitney, GKN Aerospace, Eaton, General Electric, UTC Aerospace Systems, Dell, Honeywell, Moog, Wind River, Parker Aerospace, Sargent Aerospace and Defense, and Rockwell Collins. The X-47B also integrated perfectly with the Navy's aircraft carriers. On November 26, 2012, the drone began its carrier-based evaluation aboard the Nimitz-class carrier USS Harry S. Truman at Naval Station Norfolk, Virginia. On the 18th of December 2012, it completed its first at-sea test phase and was remarked to have performed outstandingly, having proved compatible with the flight deck, hangar bays, and communication systems of an aircraft carrier. This is good news for the USS Gerald Ford protecting Israel at the moment. Imagine the X-47B transformed into an operational, more powerful, stealthy fighter drone, the X-47C. With the capability to carry a staggering 10,000 pounds of ordnance, this upgrade would turn the supercarrier into an even mightier force. And that's saying something, given that it's already one of the most formidable powers in the world. Let's dive into just how unstoppable this new combination could be, beginning with the largest aircraft carrier in the world. 25% of the world's aircraft carriers belong to the US, and their total deck space is more than double that of all other nations combined. The leader of this massive American fleet of impressive aircraft carriers is the USS Gerald Ford, and here are some reasons why. The USS Gerald R. Ford, CVN 78, is the peak of naval expertise. It represents the United States Navy's technological skill and military strength. This ship is the leader among the Gerald R. Ford-class aircraft carriers. It's a way of showing respect to the 38th President of the United States, Gerald Ford, who made a significant impact during World War II while serving on the Monterey, a smaller aircraft carrier. The construction process of the USS Gerald R. Ford began on August 11, 2005, and it was marked by Northrop Grumman's ceremonial steel cut for a 15-ton plate integral to the carrier's sideshell unit. This important occasion was the beginning of a project that would redefine naval capabilities in the United States. The keel of the carrier was laid down on November 13, 2009, setting the foundation for a vessel that would consist of the latest technology and power. It was named on November 9, 2013, with Susan Ford as the ship's sponsor. The USS Gerald R. Ford was a symbol of American naval innovation. Its construction was a massive project, and it reflected the commitment of the United States to maintain naval supremacy among other countries. The carrier's acquisition took place on May 31, 2017, and it was formally commissioned on July 22, 2017, in a ceremony led by President Donald Trump. The USS Gerald R. Ford was a technological milestone that came with a large financial investment. It cost an estimation of over $12.8 billion, coupled with an additional $4.7 billion that was used for research and development of this project. The carrier was tested and brought to life by Newport News Shipbuilding. The carrier's motto, "Integrity at the Helm," highlights the values and principles that this carrier upholds as it operates on the global stage. This carrier has no rival when it comes to its size and capabilities. With a displacement of about 100,000 long tons at full load, it boasts a length ranging from 1,092 feet to 1,106 feet. The carrier's flight deck spans an impressive 256 feet in width, while the waterline beam measures 134 feet, standing at a height of 250 feet and comprising 25 decks. This floating fortress represents a formidable presence on the world's oceans. Two Bechtel A-1B nuclear reactors, the most cutting-edge engines created for use on water, power the USS Gerald Ford. As a result, the carrier would only need to be refueled once over its entire 50-year operational life, as these engines make use of the everlasting nature of nuclear energy. This means USS Ford can run for 25 years at a time without refueling, and with a peak speed of around 30 knots, the supercarrier can access every country on the planet just in time to pay friendly visits to allies and wreak havoc on enemies. The USS Ford is a marvel of modern naval engineering, combining sheer power with advanced intelligence. This balance is achieved through advanced artificial intelligence, particularly in the form of unmanned vehicles that are making waves on their own. The carrier's extensive automation means it requires fewer crew members than a ship of its size would typically need. This reduction in crew frees up valuable space for extra systems, advanced weaponry, and luxury features like ergonomic living quarters and state-of-the-art gymnasiums. These improvements drastically enhance the quality of life for the 4,500 crew members, which is vital because a carrier's effectiveness hinges on the well-being of its crew. With a satisfied, well-cared-for team, the USS Ford is always in top form, ready to tackle any mission with unmatched agility and precision. Let's talk about the new sensors and processing systems. The USS Gerald R. Ford features the latest sensors, processors, and weapons needed on an aircraft carrier to maintain that balance of intelligence and lethality. Unlike virtually every other aircraft carrier in the world, the USS Ford features a single system for both horizon and volume search in the form of the AN/SPY-3 multifunction radar for X and S-band active electronically scanned array. It remains the most advanced radar system from the US, with enough versatility to handle surveillance, air traffic control, missile communications, and spot targets from miles away. Also, up to 75 fighter jets and unmanned aerial vehicles can call the USS Ford home at a time, including the Navy's favorite child, the fifth-generation F-35C Lightning II Joint Strike Fighter, whose development program remains the most expensive weapons development program of the Pentagon to date, with a reported cost of $400 billion. The result of such an expensive program is a fighter that really can do it all: close air support, vertical takeoff and landing, and everything in between, cementing it as the modern go-to fighter for the Navy and every other military department. That is, until the sixth-generation F/A-XX fighter takes center stage, of course. And for when that happens, the USS Ford is already equipped with the technologies required to host, launch, and arrest it. An electromagnetic launch system catapults manned and unmanned aircraft to the sky in the shortest possible distance, and an arresting gear saves them from becoming sea divers by grinding them to a sharp halt. An elevator system is responsible for swiftly moving aircraft and weapons within the carrier between lower and upper decks. The electromagnetic launch system on the USS Gerald Ford, developed by General Dynamics, is the most advanced in the world. Each of these $450 million systems can launch 4,100 aircraft before faults and packs 29% more power than its steam-based predecessor. USS Gerald Ford has 4 of these electromagnetic launch systems. The arresting gear on the USS Gerald Ford is also the most advanced in the world. The $700 million system can handle 16,900 arrests before faults and executes its tasks far more effectively than its predecessor. The carrier has 4 of these arresting gears. The elevator system on the USS Gerald Ford is a 180 million system packed complete with sensors and computerized controls that allow lightning-quick movements around the gigantic ship. The carrier has 11 of these elevator systems. With its state-of-the-art launch, arrest, and elevator systems, the USS Gerald Ford can swiftly and efficiently handle a diverse range of aircraft like no other carrier in the world. So what do you get when you combine one of the planet's most formidable aircraft with the most powerful aircraft carrier in history? You get an X-47B drone on the deck of the USS Gerald Ford, a sight that Hamas would dread to see, especially before the war is over. This deadly combination represents a game-changing force in naval warfare, ready to strike with unmatched precision and power. Another aircraft carrier, the drone, would have been perfect and extremely dangerous on as Russia's Admiral Kuznetsov class. The design of the aircraft carrier has a different mission compared to the US Navy carriers. The Russians call these ships heavy aircraft carrying cruisers. They are meant to support and defend strategic missile submarines, surface ships, and naval aircraft. The main fixed-wing aircraft on Admiral Kuznetsov is the Sukhoi Su-33, which can handle air superiority, fleet defense, air support, and direct fire support for amphibious assaults, reconnaissance, and naval mine placement. The carrier also has Kamov K-27 and K-27S helicopters for anti-submarine warfare, search and rescue, and transport. For takeoff, the Admiral Kuznetsov uses a ski jump at the bow. Aircraft accelerate up the ski jump with afterburners, taking off at a higher angle and elevation than from a flat deck with catapults. This method is easier on the pilot, but results in a lower takeoff speed of 120 to 140 kilometers per hour, requiring aircraft that can avoid stalling at those speeds. The cruiser role is supported by 12 long-range P-700 Granite cruise missiles, giving it the designation Heavy Aircraft Carrying Missile Cruiser. Unlike most Western ships that use gas turbines or nuclear power, the Admiral Kuznetsov uses conventional fuel called mazut, which often creates a trail of heavy black smoke visible from afar. This may be due to not properly preheating the fuel before combustion. The ship's designation as an aircraft-carrying cruiser is crucial under the Montreux Convention, which allows it to pass through the Turkish Straits. The convention prohibits aircraft carriers heavier than 15,000 tons from transiting the straits, but it does not limit the displacement of capital ships operated by Black Sea countries. This allowed Admiral Kuznetsov to pass into the Mediterranean Sea, with no formal protest from any signatory of the Montreux Convention regarding its classification. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.